So now we switch to English. The edge computing world rated Pratexo to the edge startup of the year 2011. And within the ABB Electrification Startup Challenge, you were rated as the winner in 2022. Blaine Mathieu, a former Gartner analyst, software company founder, CEO, multi-time CMO, and Chief Product Officer, now will give us insights about how can hybrid edge to cloud computing save industrial IoT and AI. Welcome on stage.
Thank you, Christian.
Thank you.
All right. Okay. Guten Tag, and thank you for inviting me to speak in English at this event. Trust me, you do not want the German version of this presentation. But Pratexo is an international company. We have operations in Europe, in North America, obviously, and in Japan as well. I'm joined today by Sigrid Haberkorn at the back of the room. She's our Director of German Operations. And we're really excited to be an international company helping large industrial companies from around the globe solve some of these problems and these challenges in the real world that are facing them that can be solved by the edge and cloud working together. I'm based in the San Francisco Bay Area, although I am a Canadian, and I can actually prove it. Check that out. Our development operation is actually based out of Sweden. The company was originally founded in Norway. We've got a number of folks in Austin, Texas as well, and Tokyo. So we're spread all over the place. So let's dive right into it. Saving industrial IoT and AI. Maybe that's a little bit of an exaggeration, but I think hybrid edge to cloud computing could definitely help IoT and AI. This is what gave me the first clue that it needed some help. So I'm a student of Google Trends and I follow what people are looking for and searching. And a couple of years ago, I noticed that searches for IoT and machine learning, the most common type of AI used in industrial systems, were starting to top out. Why was that? What was happening, right? And I've been in this space directly for most of the last decade. I saw around 2014, you have a lot of pilots, a lot of projects first start and launch, but then something happened around 2019. And I think what happened was we're all trying to move down this value spectrum, and I'm sure you've talked a lot about this today in German. You got to start by just collecting and analyzing data, keep it from being dark, so-called dark data. Then set up basic alerts and notifications, then gradually move toward predicting things, preventative maintenance related systems, and then finally real-time autonomous system control. That's sort of the highly efficient goal that we're sort of ultimately shooting for with many of these systems. But while that is happening, we're getting more sensors, more data, more devices, more applications, more analytics models, more machine learning models. It's getting harder and harder and more and more and more. And central cloud computing was never really designed to handle these kind of compute loads, these kind of use cases by themselves. And that's why what you see here, edge, just as IoT and AI start to top out, you see edge computing really starting to spike up. As my former colleagues at Gartner say, it's not about edge only or cloud only, it's about both of them working together. That's how you're going to be able to solve the hardest use cases and applications you're trying to get to today. So how do you take the best of edge and cloud and work them together? Well, you've spent all day listening to people talk about the benefits of edge computing by itself. I won't repeat them here. But imagine if you could join that with the notion of cloud computing, the power of the cloud, the benefits of the cloud, have resilient, scalable, reliable systems that are still running locally. They're secure, they're compliant with regulations, they're private. You keep your data local and private. They enable you to run cloud-based applications even if they are disconnected from a central cloud. And we see this in so many use cases in manufacturing and in the energy space that we're involved with. Companies want to build, they've built some really cool cloud-based systems and analytics models over the last decade. and their customers or they themselves are not ready to push all this into a central cloud. They need to be able to run in a highly reliable way, even if they're disconnected. And of course, you have to have an ability to deploy these applications, these analytics models, all the way from the far edge up to a central cloud, and we're going to talk about that. So imagine a scenario where you have compute nodes that are processing data locally and unveiling the power of all this dark data around an energy grid or a manufacturing operation or a smart city. And where it makes sense, these compute nodes are connected together into what we call a microcloud. It could be a distributed set of nodes that are working together to form this cloud, or they could be co-located. Could be a little rack full of compute nodes. Of course, you might want to create multiple tiers of these so-called microclouds. So it's not just about one level of cloud. You might have a local cloud, a regional cloud, and then a central cloud perhaps run on one of the hyperscaler systems, Azure, Amazon, Google. We see them all the time. And again, it's not about edge or cloud, it's edge and cloud. So this presentation is intended to be a solution talk. So I'm going to talk about, I think, 4 solutions that have been built on top of Pratexo, and then I'll very quickly show you how they actually did it. First solution is around grid monitoring. We know the Norwegian grid is one of the most stressed in the world. 70% of vehicles in Norway are electric right now. It's really the harbinger of where every other country is moving very quickly. And they've got a challenge because at 5 o'clock, everybody goes home, plugs their electric vehicle in, and the power grid goes under extreme stress. And so they have to work very hard to understand the exact state of the grid in real time so they can respond to those stresses appropriately. So what we're doing in the Norwegian power grid is we're setting up edge compute that's running across hundreds, ultimately thousands of distributed transformer stations. Each of these edge nodes is running software that is first ingesting the formerly dark data that was coming off these transformers and a bunch of other sensors and devices that are connected to these transformers. Prior to implementing this, most of this data was dark. By Norwegian law, you cannot push this kind of raw IoT data over the public internet for security reasons. They don't want their grid to get hacked. Good idea. So we're finally being able to process huge amounts of data in real time. And now that we've got the platform in place, we're putting in the next level of applications to run. For example, each of these nodes now has a microphone connected to it that's listening to the sound the transformer is making. It's running a machine learning model to detect the sound of partial discharge, which is a sound transformers make when they're starting to become less efficient and ultimately stop working. Prior to that being implemented, Lars there had to trudge through the snow every couple of weeks, open the door, and literally listen to the sound the transformer is making. You could not possibly push sound files from thousands of microphones up to a central cloud to do this analytics. This could only be done on the transformer edge. Fundamentally, reducing maintenance cost, ensuring the system is up and reliable, helping it run at peak efficiency. And by the way, obviously, this is critical to Norway's and all of Europe's sustainability goals, is driving the decarbonization by enabling the electrification of your systems. Let's talk about another one. Yes, Christian mentioned ABB at the beginning. We did win the ABB Startup Challenge. Over 100 companies were working to win this, and we did last May, almost exactly a year ago. Really interesting edge use case. So you can imagine that companies that are implementing complex industrial systems have lots of machines. They're all interacting together in complex ways. And when things don't work as they're supposed to, normally what happens is a human expert in those machines, or maybe it's a set of experts, has to get together and try to figure out what is going on. Like, why are these machines malfunctioning? Why are they interacting in a way that we did not understand? Meanwhile, the system is down, it's not working, it's not efficient, it may be costing millions of dollars a day. Well, we worked with ABB to take the expertise of those human experts and put it into a system that can analyze data in real time on the machine edge, And yeah, here's a screenshot of the connections to the different data sources. Some are real-time streaming sources from the edge. Some are offline data sources, right? They don't have to be real-time streaming. Here's an example of some of the outputs, and the difference between a predictive maintenance system and a root cause analysis expert system is an expert system actually figures out what went wrong and gives you recommendations for what you can do about it. We're now working with ABB to implement versions of this system along with many pieces of their equipment, machines, and other types of systems over the next few years. Let's move to the third solution. Actually touching on EV charging, I mentioned Norway earlier. Obviously, there's just a boom in acceptance of electric vehicles across Europe and across the world today. And there's some companies doing some really interesting things in this space enabled by edge to cloud software. One of them is a company called Eliware. I recommend you check it out. So they've got a really interesting system, almost a virtual power plant, because it is huge battery packs, grid connected, solar enabled. They have the ability to decide where they're going to draw energy from in any particular moment when you're charging electric vehicles, including possibly giving power back to the grid. In fact, let me show you a picture here. So these things are mobile. They can be put in the back of a truck, dropped anywhere very quickly, get one of these up and running in a few weeks, instead of it takes up to 2 years to provision an electric vehicle, a charging station today. These can be running in less than 2 weeks. You see the large battery packs on the back, so they can decide or figure out in real time when is it right to charge a car from the battery or to take power directly from the grid. And because they're mobile, they can't always guarantee they will have a high-speed, always-on connection to a central cloud. So they have to be able to run the control software for these systems on a local microcloud, like I was talking about earlier. In fact, when they built the first beta versions of the software for this system, they were using a hyperscaler cloud. I won't mention the name because they're a great partner of ours. It worked fine in the lab, but when they got in the real world, they found the 1.5 second latency it took to send the 2 Teslas roll up, plug in, data goes up to the central cloud, analyze it, figure out what to do, send the control signal back down to the machine. It's too long. Need near zero latency to be able to run these systems. Plus, they can't guarantee when they drop one of these things down, they're going to be connected anyway, right? So our software is the brains that's running these systems in a micro cloud on the edge. But I think I've got a picture of the architecture here, yes, but still cloud connected. So everything below the green line is running on the edge, on the charging edge, so to speak. Everything above the line is running in one of the hyperscaler clouds or connected to one of the energy producers clouds, which is telling Eliware how much energy is available. Should you be drawing off the grid right now or not? Really cool use case for edge to cloud computing. And a lot of benefits, as I said, hard real time, run even when these systems are disconnected. And then this last one I want to touch on, because this is going to become, if you haven't heard much about the flexibility markets yet, you're going to hear a lot more about this as part of our sustainability push right now. That's the last solution I'm going to talk about. There's many names for this space: flexibility markets, FFR, fast frequency response, frequency regulation, power reserve. You're going to hear a lot of terms, but the basic concept is pretty simple. The Europe power grid runs at 50 hertz. The US power grid runs at 60 hertz. When there's an imbalance between the power that's generated and the load that's pulled off the grid, that frequency drops. And if the frequency drops too much, your power goes out. This is not a good thing at all. In fact, since some of my team is in Texas, this is an example of what happened on February 15th, 2021. This was on the global news. Texas was basically without power for almost 5 days during a winter storm, right? It all began on February 15th around 1:30 in the morning. You can see the 60 hertz line there, when all of a sudden, because it was a winter storm, the solar panels weren't producing, the windmills all froze up, and everybody was turning their heat up, the grid could not keep up. And as you can see here, they began rolling outages throughout most of the state of Texas that ultimately lasted almost 4 days because of all the equipment damage and everything else. Texas is now, I was reading a report today about how they are rapidly embracing these power balancing markets, because if they can have the power consumers, whether it's a large building operator, a large manufacturer like Tesla, or even a company like Anywhere that has large banks of batteries, if they can, in less than a second, throttle back their use of energy or give energy back to the grid, they can prevent this kind of frequency drop from happening. This is rolling out now across most of the countries in Europe over the next couple of years, and there'll either be, penalties if for large power consumers that don't take part in these markets, or like what's happening in Norway right now, big bonuses and benefits for companies that join. If your company is a big consumer of energy, you put in systems that are able to accommodate these real-time fast frequency changes by throttling back some of your energy use in an intelligent way. This has to be done on the edge, working in conjunction with the signal coming from the power grid operator's cloud. The time scales involved, again, are less than a second to make this happen. This is going to revolutionize the reliability and stability of our grid. And as you have this widely distributed, increasingly complex power grid coming online, there's no other solution. It requires the edge and the cloud to work together. Oh, here's actually, I forgot I had this, a little picture of the high-level architecture for this particular solution. So again, integrated into a number of cloud-based systems, but everything in the middle is run on the machine edge, basically close to wherever the energy is being consumed. So, critical for grid stability, which is important to all our operations, reducing our cost of power consumption. And in fact, we're going to see not just reducing costs, but actually being paid bonuses, rebates, and other huge incentives for taking part in these markets. Otherwise, our grid is just not going to be able to support what we're trying to do with our sustainability initiatives right now. And for those companies that are implementing actual energy storage, implementing battery systems and things like that, then they can also take advantage of these markets by pushing energy back to the grid when it's really needed. So I think that was my last solution example. Now I'll talk about the Pratexo solution itself that enabled these systems to be stood up so rapidly. So we call it the Pratexo Studio. And what it does fundamentally is help an architect or a system integrator or even our own professional services design the software components and architecture that's necessary to support one of these use cases. Run simulations on it before any hardware devices, any edge computers, any IoT sensors are connected. Run complete end-to-end simulations. Then, of course, you have to be able to deploy this system to the real world, manage and monitor and evolve it over time. Because one thing we're seeing that's really important is many of these pilots, they start small, right? They start with a very sort of quick and relatively easy use case, but the vision for what they want to do is quite large. And like in the Norwegian power grid example, the first example I gave, the Norwegian grid operators now have 14 different use cases they want to, over the next few years, stage on top of their edge to cloud platform. And now that the platform is in place, they can much more quickly put the next one and the next one and the next one. Even things that you wouldn't think of, site security. So using object detection to know if an animal or a person walks in front of the remote transformer station, right? That's one use case of the application of AI on the edge. That's not directly related to the grid operation itself, but it's something that can easily be deployed once they've got that standard edge compute use case and platform in place. Yeah, I've got a picture of the platform working here. So this this is actually the software architecture that's running in the Norwegian power grid right now. You've got sensors and devices on the right-hand side that are defined. In the middle, you've got software components that are being deployed to each individual node running at each individual transformer station. And on the left, you've got software that's being deployed to groups of nodes across sets of transformer stations. This is the microcloud concept. So you have software, in some cases it's containerized, in some cases it's running locally. In some cases, like the software in the middle, it's running on each individual node. And on the left-hand side, it's running across sets of nodes, giving that reliability, that scalability, that failover. This definition of the device types is really important because it enables real-time simulations to be generated very quickly. So when the architect or the system designer is ready, they can not only deploy this complete software architecture to a cloud for testing before you have to push it out to the edge, and all the data streams that you've defined from those devices are also simulated. So you can run a complete end-to-end simulation of your system, of your application before any physical device is connected anywhere. It's very powerful, and it all happens automatically. And then finally, when you're ready, you define your edge architecture, what kind of machines, how powerful are they, how do you access them, and then you deploy out to the physical edge. Or again, I'm saying, I'm using the word edge loosely. What I really mean is anywhere from the far edge, really up to and including a central cloud, because you can deploy the software components that I saw even into Azure or AWS. It's not only deployable on a little edge node running at the far edge. You define where you want it deployed from the edge all the way to the cloud. So think about it this way. The studio enables that design, simulation, deploy management of applications and architectures that will run from the far edge all the way to the central cloud, like I just mentioned. And because frankly, doing these things are very complicated. I know you folks know this, right? Building these systems, testing them, deploying them, this is all pretty new. And the core concept of the Pratexo Studio is, instead of doing every one of these projects sort of for the first time, we've taken the expertise of folks that have built many of these systems, some at massive scale, and put it into the platform. So the platform knows how to deploy these components. It knows how to integrate them together. It knows how to make them talk to each other, right? And that's what gives that acceleration and that de-risking of many of these projects. All the projects I showed you previously, those 4 solutions, they're all deployed in weeks, not years, but weeks. So to wrap it up, what makes Pratexo, I think, sort of unique in this space? Well, we do have these things called solution frameworks. The solutions I talked about earlier, we've actually, you might say, productized them, turned them into highly customizable frameworks that could be easily implemented in many different scenarios, like the expert system, the grid monitoring system, and others. So we've tried to accelerate work even more by not only giving you a core platform, but giving you starter projects on top of the platform is probably the easiest way to think about it. Then there's the fact that it's not only about edge or only about cloud, but it's about putting the analytics, the data, the applications where it's most appropriate. And then the notion of the studio itself, the low code or really no code system that makes all this happen. That's why we now have a global partnership with Cognizant, is now building applications and solutions for their customers on Pratexo. The head of IoT in Japan said to us about 9 months ago, what you showed me in 15 minutes or 10 minutes would have taken my team 3 months. And that's why Cognizant is using Pratexo today. And that's why we're excited about what we're doing. And there you go. That's how we break the cloud challenge, and we use hybrid edge to cloud computing. And obviously, there are lots of ways to do this. I'm sure you've talked about a lot of them today. We definitely believe that Pratexo is a way to accelerate some of those efforts, not as a replacement, frankly, for many of them. I didn't mention, but Pratexo is fundamentally open. All the components we deploy are by default open source components, and we have a way to build in your own custom features and analytics models as well. But the platform is open. All Pratexo does is accelerate your work. It's not a black box. When you're running a system with Pratexo, you own it. You know exactly what's inside. All the components are yours. There's no black boxes. right? There can't be in the space we're in right now. So I think we have a few minutes for Q&A, and Sigrid Haberkorn, I'll ask Sigrid, why don't you pop on up? Obviously, feel free to ask me questions in English. And Siggy, I've been working with Sigrid for over 10 years in this space at a few different companies, all in the industrial IoT, industrial automation space. So Siggy, as I call her, knows this. There you go. Perfect.
Each other for
You do.
we know each other for
Isn't
15
that
years
nice?
now.
Isn't that nice? She knows the space as well as I do, and been working with, I think, many of you over the years at various companies. So happy to take some questions if we have time.
Yeah, we have, definitely. So thank you very much. It was an amazing presentation. And I hope we have some questions. Otherwise, I have some.
Don't be shy. I'm nervous about a question from you because I saw your presentation before and it looked very good, very impressive. So, but go ahead.
No problem, but I will ask you in English. Yeah, thank you for your presentation, and it's really amazing technology. But I'm wondering how the users can use it. I know it from many low-code platforms. They use this citizen development, they called it, that the user can do the development by themselves. And they have huge problems that the people don't do it.
Yeah.
So, and your interface looked similar. So I was wondering, do you have a special education process for your customers? Or how do you face these problems?
It's a really great question because there are two types of customers, you might say. There are the customers that have the technical know-how to understand what Mongo and Kafka and Kubernetes and these kind of systems and components do and how they work, right? And again, we're not replacing Kubernetes and Kafka and all these technologies. We're enabling somebody who knows how to use them to get them integrated and deployed and managed much more quickly and easily. So if you're a company or an organization that already understands some of these core technologies, then you would find using this platform very, very a real accelerator. Now, we have many end user customers of ours that aren't experts in these technologies, that don't want to be, okay? So in their case, either we will actually develop the solution for them using the platform, so it's fast and easy to manage and change, but we will develop it, or we'll bring in a system integrator like Cognizant to do that work. So our goal is definitely not to make everybody in the world experts in event stream processing using Kafka. You know, that's not the goal, that's for sure. But some organizations have that and they're ready for it, and some aren't. In that case, no problem. We'll take care of that low-level stuff, but you'll still benefit from the platform because it allows you to change and evolve and add new applications and analytics very quickly over time. Great question. Thank you.
Then I have a question again. I've probably two ones. So first of all, how do you manage all these devices? Because you said it's security, and also how do you do this, and how you get all this data together, and how do you on a physical basis, on a technology basis, how do you do it?
Well, obviously that's a big question, and device management is a very complex topic altogether. What I would say is for smaller and simpler applications where the number of devices is not that high, not the raw number of devices, but the variability in the different devices is not that high, then we do what I'd call basic to mid-level device management right in the platform. Now, if a company is doing very complex rollouts of a large number of many different types of devices, then we actually leverage the hyperscaler device management solutions. So, you know, Azure IoT does a really great job of device management, in particular, AWS to some degree, and so we build deep integrations to all the major hyperscaler clouds, and that's how we handle more complex device management. Is that they do what they do best, and we'll do what we do best.
Perfect. Thank you very much.
Yeah, just to make that point, every implementation we have involves one of the hyperscaler clouds. So again, it's not about using Pratexo or Azure, right? It's about using Pratexo to accelerate what you're doing with Azure, it's not an either or.
Thank you. Do we have for one more question? Or don't we have? No, it's that was a no. You started saying no. Okay, so then I keep the question. I ask it privately afterwards. So
Okay,
thank you
all.
very much.
Appreciate it. Thank you, Sigrid.
Sigrid, hi. Ja, wir sehen uns gleich. Thank you very much for the presentation. Thank you. Thank you.
So.